Students, today class AC circuits. The previous video, the important definitions of alternating current. So what is the alternating current? The current which varies periodically with time is called alternating current. So there are two types of current. One is a DC current, another one is a AC current. DC, a direct current. The flow of current, the direction of flow of current remains same with a time, that is a DC. The direction of flow of current remains same with a time. The direction of flow of current periodically vary with time, that is the alternating current. So now here two types of circuits, one is the DC circuits and AC circuits. Example, DC circuit, a resistor. Resistor, this is a symbol for resistor. A resistor R is connected in series with battery or source. So in battery means two polarities, positive polarity, negative polarity. Battery means a source of EMF or a group of cells. The current I is a current coming from the battery. Now in the DC circuits, so you indicate battery polarities and also you show the direction of the current. This is very important. DC electrical circuit. This is called DC circuit. A resistor connected in series with a battery or source of EMF in battery. So you must should indicate polarities positive and negative. And also you show the direction of the current. So this is the DC circuit. So how to write AC circuits? Example, a resistor. A resistor R is connected with series with an AC source. So in source, do not mention for polarity. This is a AC source. So in AC source, you do not mention for polarities and do not mention for arrow mark for current. So this is the main difference between AC and DC circuits. In DC circuits, in battery, you mention polarity is positive and negative, and also you show the direction of the current. In AC electrical circuits, a resistor R is connected in series with an AC source. In source, you do not mention polarity and do not you show the arrow mark. Do not mention the arrow mark in current, because in AC electrical circuit, every half cycle directions must be changed. A voltage vary like a sine function with time. That is called alternating voltage. So already you know the definitions for alternating voltage. A voltage vary like a sine function with time is called alternating voltage. So every half cycle directions must be changed. Therefore, you do not indicate direction of the current. So this is the main difference between AC and DC electrical circuits. In DC circuit, must and should you mention polarity and also show the direction of the current. In DC circuit do not mention polarity and also direction of the current. This is the difference between AC and DC electrical circuits. Now students, AC circuits, the first circuit, AC circuit containing few resistor. AC circuit containing few resistor. A few resistor of resistance are connected in series with an AC source. This is AC source. V equal to Vm V naught or Vm sin omega t. A few resistor R is connected in series with an AC source. The AC source V equal to Vm sin omega t. So already you know the equation in the last class. V equal to Vm sin omega t. V is a instantaneous value of alternating voltage. Vm is a peak or amplitude of alternating voltage. Sine is a simple harmonic function. A voltage vary like sine function. Omega is a angular frequency of AC. So V equal to Vm sin omega t. Now the alternating source, the AC source applied to a few resistor. In a few resistor circuit, a voltage and current line. So how they are vary sine function with a time. You know the first diagram here. Phasor. What is a phasor? Phasor is a vector. Phasor is a vector rotating about origin in an anti-clockwise direction with a constant angular speed. Now example here, voltage line and current line. So now this is a voltage line. The alternating current passes through a few resistor. In that few resistor circuit, what happened? The voltage and current line. So this red color line may be voltage. So this is a blue color line may be current. So here the two lines are two phasor is rotating about origin in an anti-clockwise direction with a constant angular speed. Now you refer the 2 points here. One is a voltage line, another one is a current line. The magnet of the phasor represents peak value. The magnet of the phasor represents a peak value. So this is a voltage, this is current line. For example here, the voltage and current line is separated, rotating about origin in a anti-clockwise direction with a constant angular speed. Now the magnet of the phasor, the length of the magnitude is it. So the magnet of the phasor represents peak value. So this is the voltage peak value V0, current peak I0. So now voltage and time, how they are vary. So already you know the definition of alternating voltage. The voltage vary like a sine function with time. So now observe this line. This is the voltage line. This is the voltage versus time. The voltage vary with the sine function with time. That is called alternating voltage. The voltage vary with a sine function with time is called a alternating voltage. And even the current line, current also here, current vary with the sine function with the time, alternating current. Now in this graph here, the voltage or current taken along the y-axis, so omega t taken along the x-axis. Voltage and current, how they are related. So already you know the definition of the alternating current. A voltage vary with a sine function with time is called alternating voltage. And current also vary with the sine function with time is called alternating current. So now in this graph here, this is a solid line. The solid line represents what? Voltage. A dotted line, this dotted line represents current. The maximum value of voltage is called peak value or amplitude. This is V0. The magnet of the phasor represents V0. Here also the maximum value of voltage is called peak value or amplitude. Here maximum value of current is called peak value I0. So a voltage and current line, so same phase at same time. The voltage and current line same phase at same time. So how much phase means angle. Then how much angle is there? Pi. Voltage line also pi. Current line also pi. Here also at same time the voltage and current is same phase. Per time means the time taken to complete one cycle is called a period of AC. The time taken to complete one cycle, the time taken by alternating current to complete one cycle is called a period of AC. Period represents symbol capital T. So in half filled T by 2, here T by 2. So same phase, current and voltage are at same phase at time T by 2. So what is the phase difference of voltage and current? Phase difference. Phase difference. So phase difference, here voltage line also pi, current line also pi, how much? 0. So what is the phase difference between voltage and current in a few resistor? This is the one mark question. So same phase at same time, no difference, difference is 0. The phase difference between voltage and current is 0 in few resistor, except few resistor. And one more phase here, 2 pi. So 2 pi at same time. So voltage line also 2 pi, current also 2 pi. How much? 0. So in this graph, it shows that current and voltage vary a sign function with a time. But current and voltage have same phase at same time. So time T by 2, how much phase is there? Pi, both current and voltage. Therefore, the phase difference between voltage and current in a few resistor, pi minus pi equal to 0. So now phase difference voltage and current in a few resistor 0. And one more point here, 2 pi at same phase, current and voltage at same time. So totally the phase difference between voltage and current is 0. AC circuit containing few resistor. So students, now we are to see that a few resistor R is connected in series with an AC source. The AC source V equal to Vm sin omega t. V is a source voltage. Vm is a peak value or maximum value. Omega is an angular frequency. T is a time. The alternating source applied to a few resistor in that circuit a current and voltage. How vary with time according to simple harmonical function sine function. Now we have example here. A voltage line and current line. Example here. So voltage. This is a red color line voltage. This is a blue color is a current. So both are rotating in a anti-clockwise direction with a constant angular speed. So this is the magnitude. The voltage line red color, the magnitude of the phasor represent V naught. And a blue color, so current may be the magnitude of the phasor represent V naught. Example now here. Now two fingers. This is the voltage, this is the current. Two lines are get separated, but same phase, same time, both are rotating in anti-clockwise direction with a constant angular speed. Now this voltage line varies sign function with time. Current line also varies sign function with time. So that is alternating voltage or current. So this graph shows that same phase for both current and voltage at same time. So the phase difference for voltage and current is 0 in few resistor, except few resistor. So this is the AC circuit, first one, AC circuit containing few resistor. Now second circuit, AC circuit containing capacitor. So already you know the definition of capacitor. Capacitor is an arrangement for storing electric charge. Essentially, it consists of two parallel conductors get separated small distance with a dielectric medium. One plate carrying positive charge, another plate get negative charge, storing electric charge. What is a capacitor? Capacitor is an arrangement for storing electric charge. Now, a pure capacitor C is connected in series with an AC source. Connected in series with an AC source. The AC source voltage V equal to Vm sin omega t. Now you observe your circuit without indicate polarity, without mention aroma in AC electrical circuits. This sign symbol represents AC source. Friends, you observe carefully. This sign symbol represents AC source. So you do not mention polarity and arrow mark. So V equal to Vm sin omega t. V is a source voltage. Vm is a peak or maximum value. Omega is a angular frequency of AC. Now alternating source passes through a pure capacitor. What happened? Current and voltage. How they are vary? Current and voltage vary with time according to sine function. So now voltage and current vary. The two lines, how much difference is their angle? 90 degree. So in a previous case, voltage and current have same phase. But in a pure capacitor, voltage and current line get separated. Example, here show this is the voltage line, this is the current line. Example, this is the voltage. Now here, blue color is the current. So students, now you look at here. So a red pen, it shows that voltage. A blue pen, it shows us current. So how much difference is there? Example, so 90 degree. So this direction. So carefully you observe a voltage and current. So lines get separated. A red color it shows voltage. A red color line, red pen. A blue color pen, it shows current. Both are rotating in what? Anti-clockwise direction with a constant angle speed, that is called a phasor. The magnitude of the phasor represents V naught. Here also the magnitude of the current I naught. So I naught, the voltage and current, how much phase difference here? Angle 90 degree. So here 45 degree, here also 45 degree. How much is there? 90 degree. For example, now this structure. In previous case, a pure resistor and voltage what? Current and voltage are same phase. This is a pure resistor. This is the voltage, this is the current. Both are rotating in anti-clockwise direction. But here capacitor may be this structure. This is the voltage, this is the current, are rotating in anti-clockwise direction. You carefully observe students this point. The alternating source applied to a pure capacitor. So in the AC circuit, this is the voltage, this is the current. How much difference is the angle? Phase difference in voltage and current? 90 degree. So now voltage, how vary with time? The voltage vary like sine function with time, that is a sine wave. This is a sine wave. A solid line represent voltage line. And current also vary with the sine function. This is a sine function. Now here a different phase at a different time. So here current line pi by 2. Pi by 2 what? 90 degree. Voltage line what? Pi. Pi means 180 degree. And once again here current line 3 pi by 2, 270 degree. And voltage line, how much pi? 2 pi. Now each successive difference what? 180 minus 90, 90 degree. 270 minus 180, so 90 degree. 360, 270, 90. And now this graph it shows that the phase difference between voltage and current, how much angles there here? 90 degree or pi by 2. This is 1 mark %. 90 degree or pi by 2. 90 degree or pi by 2. This is the phase difference between voltage and current in a pure capacitor. So I repeat one more time. A pure capacitor R is connected in series with an AC source. So the voltage line, this is the current line, maybe the structure. Red color indicate voltage, blue color line indicate current. How much difference is the angle? 90 degree. The voltage line vary with sine function with time. Current line also vary with sine function with time. So this is the alternating voltage. Now the phase difference between voltage and current line in this graph which indicate 90 degree. This is the 1 mark question. What is the phase difference between voltage and current in a pure capacitor? 90 degree. Now AC circuit containing inductor, so inductor symbol. So observe carefully symbol. The symbol indicates inductor, a fine copper wire wound several times. That is the symbol for inductor. A pure inductor of inductance L connected in series with an AC source. So V equal to Vm sin omega t. So V is the same source voltage, Vm is the peak or maximum value, omega is the angular frequency. The alternating source, the alternating current passes through a pure inductor. In that circuit, a voltage and current, what is the behavior, what is the character of the lines. So now here a red color indicates voltage. Red pen it shows voltage. A blue pen it indicates current. The structure. Students, you observe carefully. The alternating current passes through a pure inductor. In pure inductor circuit, voltage and current, what is the character? How it shows behavior, how they are related. So voltage and current line it shows this direction. So how much difference is there again? Once again 90 degree. So now here phasor. Phasor is a vector rotating about an horizon in a anti-clockwise direction with a constant angular speed. The magnitude of the phasor, this is the magnitude of the phasor represents peak value. So peak voltage. Here magnitude of the phasor represents current I0. Now voltage, how vary with time in alternating current circuits. So voltage vary with the sine function with time. So this is the voltage line. This voltage vary with the sine function with time. The solid line, this is the solid line indicate voltage line. See AC waveform. And current line, now your current line will refer at this point. A current line, a current vary with sine function with time, dotted line. So different phases, different at different time. So here pi by 2, here pi, 3 pi by 2, 2 pi. So the time taken to complete, the time taken by AC to complete one cycle is called a period of AC. So your time here T by 4, T by 4th period. There T by 2 half period, there is 3T by 4. So here 2 pi, 3T by 4. So now here how much angle is there? Here pi by 2, 90 degree. Here how much angle is there? 180 degree pi, 270 degree, 360 degree. So now difference, this is the voltage, this is the current. How much difference is there? 90 degree. Here also how much difference? This is a 45, this is a 45. Now phase difference between a voltage and current in a pure inductor, how much? Pi by 2 or 90 degree. Pi by 2 or 90 degree. This is the phase difference in voltage and current in a pure inductor or capacitor. How much phase difference? Pi by 2 or 90 degree.